In this video, we're going to take a look at matrices. A matrix is a rectangular array containing either numbers or variables. Now, matrices are usually named with a capital letter. So we could say matrix A looks like 1, 6, -2. And if we wanted to talk about the size of this matrix, then we're going to write down the number of rows times the number of columns. So if we take a look at A, it's got 1 row, it's got 3 different columns. So we would say A is 1 by 3. Okay, our matrix may contain variables. So we might have matrix X, for example. Again, a rectangular array. This time it's got a single column, but it's got 2 different rows. So in talking about the size, we would say X is 2 by 1. Matrix B, let's say it looks like this. In terms of its size, we would say B is 2 by 2. And because B has the same number of rows as columns, we could actually say B is square, meaning just the number of rows is equal to the number of columns. Now, sometimes we need to talk about specific elements that appear in the matrix. So let's focus on this matrix B here. And we're going to write little b with subscript ij. And what that means is it's referring to the element that is in row I, column j of the matrix B. So if our matrix is called capital B, when we're referring to the element, normally we'll use a small b there, and the subscript just indicates the position. So we always give it as the row coordinate and then the column coordinate. So for example, if we write B12, that would refer to the element that is in row 1, column 2 of our matrix. So B12 would be 3. B22, for example, would be the entry in row 2, column 2, so that would be 1. B21 will be the element in row 2, column 1, so that would be 7. B11, the entry in the first row in the first column would be -2. Now, just a little bit of terminology here, since we are getting into our discussion of matrices. Notice that we say one matrix, but if we want to pluralize that, we say 2 or more matrices. So just a little bit of terminology that might be helpful as we're going through this section. Okay, for our first example, let's see if we can find the values of x and y given a little matrix equation. So we've got one matrix here that contains some variables and some numbers. Let's say our first matrix looks like this. And let's say we're given the fact that our first matrix is equal to 9, -7, and 5. Well, to say that these two matrices are equal is really giving us 3 separate pieces of information. In order for 2 matrices to be equal, we need all the corresponding elements to be equal. So it's saying the top positions are equal, 2x plus 1 is equal to 9. It's saying the entries in the second row in the first column, 3y minus 1, that must be the same thing as -7. And similarly, coming from the third row, we get 5 is equal to 5. So we're really getting 3 pieces of information here. The top 2 equations will allow us to solve for x and y. So let's take a look at our information coming from our first row here. Subtracting 1 from both sides, we've got 2x is equal to 8. In other words, x is equal to 4. And the information coming from our second row, if we were to add 1 to both sides, we'd get 3y is equal to negative 6. So y is equal to negative 2. The bottom row, 5 equals 5, that gives us no information. So that part is irrelevant to the problem. Just the top two equations allow us to solve for x and y. So x is equal to 4, y is equal to negative 2, and that would be our answer there. Now to finish off our introduction to matrices, we're going to look at a couple of operations that we can do with matrices. There's our matrix A, and we'll grab a matrix B as well. And let's do a couple of calculations here. So let's start off with finding something like A plus 4 times B. Okay, well, let's write out this expression and see exactly what's going on here. We've got the matrix A plus 4 times the matrix B. And just like with real numbers, we're going to do the multiplication before the addition. So we're going to think about what 4 times B really means here. Well, whenever we have a number multiplying a matrix, what we're going to do is just go through and we're going to multiply each element of our matrix by that number. So each of these elements inside B are going to get multiplied by 4. So A will stay the same for the moment, and we'll be adding on 4 times B. So multiplying everything through by 4, we get 8, 4, 8, 0, 28, and minus 12. Okay, so that tells us how to multiply any number times a matrix. Now that we've got that part done, we can do the matrix addition. And so what we're going to do here is we're just going to add the corresponding elements together. So if we look at our top left position in our two matrices, we're going to go 1 plus 8 is 9, and we're going to go through and do each of our addition operations on each separate element of the matrix. So moving across that top row, we're then going to pair up the negative 6 and the 4. So negative 6 plus 4 is going to give us negative 2. 3 plus 8 will be 11. And we'll do the same thing all the way through the bottom row. So you can actually just imagine the two matrices sliding on top of each other and just adding the corresponding elements, if you prefer to think of it that way. So 4 plus 0 gives us 4. 1 and 28 gives us 29. And then finally, negative 2 plus negative 12 gives us minus 14. Okay, and we're done that calculation there. For part B, let's try doing A minus B. So we may well have subtraction of matrices rather than addition. It might be helpful just to write out the matrices again so we've got them here to look at. So we're taking our matrix A and we're going to subtract off our matrix B. Okay, and again, we're just going to do the operation one element at a time. So if we look at the top left position here, we're going to go 1 minus 2 is negative 1. And as we go through this, we'll just have to be very careful about the signs because we've got this negative sign here. So subtraction is always a little bit trickier than addition because we have to keep remembering that sign there. Negative 6 minus 1 gives us negative 7. 3 minus 2 is 1. And then moving down into the bottom row, we've got 4 minus 0 is 4. 1 minus 7 is negative 6. And then negative 2, really minus negative 3. Got a double negative in here. So it's like negative 2 plus 3 is going to be 1. Okay, so that shows us how to handle subtraction. We also looked at how to add matrices together, and we saw what it means to multiply a number times a matrix. So those are our basic arithmetic operations. Now, just as a little comment here, the operations of adding a matrix together or subtracting one matrix from another, these operations are undefined if A and B have different sizes. And that's one reason why we looked at sizes at the beginning of this video, was just so that we could recognize when two matrices are going to have compatible sizes. If you've got matrices that are different sizes, that it's unclear how to pair up the elements, and unfortunately we can't add or subtract in that situation.